Hi, I live in a coastal town. My grandparents live in the next town over. So as I was boarding the ferry to go visit them, I noticed that a huge new bridge project began right here where I live. The long-awaited infrastructure is great news to the people that live in my city, as it will boost tourism and improve the connectivity between adjacent cities. As a curious person from birth, my mind immediately started flooding with questions I didn't have the answers to yet. For example, how do they build these underwater structures? How do they get people and machines over there? And what are the impacts on the environment? So as soon as I got home, I did some research, and here's what I found out. Let's start from the beginning. One of the very first ways humans found to build a bridge foundation was by using a cofferdam. Cofferdams are temporary enclosures designed to create dry work conditions in areas submerged by water. They have applications in other fields, such as building dams, oil platforms, and wind turbines. These man-made temporary structures date back thousands of years, with records of King Cyrus of Persia using earthen cofferdams in 539 BC to divert the Euphrates River, enabling the capture of Babylon. The Romans also employed cofferdams in 102 AD during the construction of Trajan's Bridge over the Danube River. Throughout those various applications, there are several types of cofferdams, but for the sake of our bridge dilemma, we're focusing on a particular one, metal sheet piling. This process consists in driving metal sheets, or piling them, that's where the name comes from, into the sea or river bed. The sheet edges interlock into each other, maintaining a watertight seal. The water is then pumped out and the structural piles can be driven or drilled in the soil. Once the concrete is strong enough, the cofferdam can be removed. Steel sheet cofferdams were only possible thanks to the Industrial Revolution, but it was perfected in the following years. In the mid-1800s, cast iron I-beams and channels were used, but lacked ductility and were also riveted together. In the early 1900s, a German engineer called Trygg Larsen patented a hot roll section, which increased sheet pile wall strength and efficiency. Later, the interlocking edges were added, and this is the most used form of cofferdams for bridge building today. A more modern solution to building underwater is the use of drill shafts. In this process, a hole is drilled in the bottom of the waterway, and as the machine drills, circular reinforcements or casings are pushed down, preventing the soil from collapsing, but the hole remains full of water. Later, the steel reinforcements for concrete are inserted and a tramming pipe is lowered to the bottom of the hole. Concrete is poured as the tramming pipe is lifted. Since concrete is dense on the water, it replaces it in the hole, pushing the water up. Pouring the concrete from above wouldn't work, since it could mix with the water and dilute, changing the ratio of water to cement and its strength. From there, it is just a matter of building a pile cap and your foundation is done. You could mix both methods, build a cofferdam and use drill shafts to have your pile cap at the bottom. But in this case, or of this bridge, there's no need for cofferdams. In both situations, huge cranes and special machinery are sailed across the water on top of specialty boats. Workers are also transported by water, sometimes in smaller vessels. The environmental impacts of building bridges are not to be overlooked. During the construction period, water ecosystems may suffer a decrease in water exchange. Bridge foundations construction can also cause habitat destruction, biological reductions, increase in suspended solids, and decrease in water quality. As for the bridge connecting infrastructure, the building process can cause changes to the original landform and terrain, destroy surface vegetation, increase the risk of soil erosion, change the regional ecosystem, and can contaminate groundwater. This is the reason why environmental studies need to be conducted before construction ensues. A study conducted in West Virginia sought to analyze the behavior of songbirds and small mammals before and after a bridge was built in the Ohio River. It was found out that most species sampled did not respond to the bridge crossing, and they believed that the bridge was not causing any measurable negative density impacts to the investigated species. The analyzed bridge does now provide a habitat for exotic rock pigeons that are adjusted to man-made structures for nesting. The new bridge where I live will have a great economic and social impact, providing better transportation of goods and people around the nearby cities. And now I understand a bit better about what it takes to make such a huge project come to existence. I'm also glad to know more about how it affects the rich variety of plants and animals that make the surroundings of my city their home. Thank you for watching. Don't forget to give the video a like and subscribe to the channel to follow future videos. Goodbye!